Last night in your homework, you were supposed to read through section 8.1 and define the vocab words in that section. It was about vectors. Vectors have both a magnitude and a direction. The magnitude is usually the distance of the vector, and it's denoted using kind of an absolute value sort of symbol. That's the magnitude or the length of the vector. The direction is just like when we had angles in standard position. So the direction, I'd have to imagine an x and a y axis, and the direction would be this angle right there. Standard position starts on the positive x-axis and rotates around counterclockwise, just like angles did. Zero vectors don't have any magnitude, they don't go anywhere. The resultant we're going to use a lot today. The resultant is when you add two vectors together, and we're going to get that using the triangle method. If I want to know what vector p plus vector q is, I'm going to redraw them tip to tail, which is how they are in this picture. Vector p ends there, and right where it ends, that's where I start vector q. And then the result is that pink vector, the vector that goes from the very beginning of p right to the end of q. That's the resultant vector, or what I get when I add them together. Opposite vectors are vectors that have the same length, they just go in opposite direction. So if you add them together, you'd end up with the zero vector. A scalar quantity is just a number, it has no direction. When you multiply a scalar times a vector, you just have that same one. So like this is 3a because it has 3 a's. It ends up in the same direction, but its magnitude is multiplied by 3. It's 3 times as long. Parallel vectors have the same direction or opposite directions. Like these two vectors have opposite directions and they're still parallel. The big word that I really want to touch on here is components. We're going to use the components of a vector a lot. The components of a vector, if I have some vector like x, I can rewrite that vector as the sum of a horizontal vector plus a vertical vector, and those are called its components. So here's an example. A ship leaving port sails for 75 miles in a direction 35 degrees north of due east. So let's stop there. The 75 miles is how long it's been sailing, so that's going to be a magnitude. And then it tells you exactly the word direction. The direction is 35 degrees north of due east. Here's north. If we're going 35 degrees north of due east, we're going to start here and rotate around 35 degrees. That is 35 degrees north of due east. How long is that vector? That vector is 75 miles long. So the vector that we're talking about here in this example is this black one. It's 75 miles long, 35-degree angle. Now let's do the question. Find the magnitude of the vertical and horizontal components. So they want us to break this vector down into, I'm going to do the horizontal one first, a horizontal and a vertical vector. And they want us to figure out what's this and what's that. Since one of them is straight horizontal and the other one's straight vertical, it does make a perfect right angle. So we can just do right triangle trig. We know an angle. We know the hypotenuse, so to figure out x, that's adjacent and hypotenuse, we'll use cosine. And solve that equation for x. For y, y is opposite, so we'll use sine. And solve that equation for y. The book did the same thing. Our picture looks almost identical. When they solved for the y, they got approximately 43. They rounded it off to a whole number. And when they solved for the x, they got approximately 61. So the horizontal component is 61, the vertical component is 43. We're going to learn in the next section that that means we can write this vector as an ordered pair. 61 in the x direction, comma, 43 in the y direction. For vectors, we're going to use kind of pointed brackets, not the rounded parentheses like we're used to for a point, but more pointed parentheses. Another example I want to look at in this section is this one, which is on the back of your white worksheet. A piling is just a pile of stuff. A piling for a high-rise building is pushed by two bulldozers at exactly the same time. So I have this piling or this pile of stuff, and it's being pushed by two bulldozers at the same time. One bulldozer exerts a force of 1,550 pounds in a westerly direction. So it's going west, it's pushing that way at 1,550 pounds. The other bulldozer pushes the piling with a force of 3,050 pounds in a northerly direction. So now I'm pushing north with a force of 3,050 pounds. Now with this picture, exactly how it is right now, that's how it would kind of look in real life. There'd be one bulldozer right here pushing that way, pushing west. There'd be another one right here pushing north, and that's how it does look in real life, but whenever we want to find the resultant force, which is what they're asking us for, we want to redraw it tip to tail. So if I'm redrawing this tip to tail, I'm going to start with my 1550 force. And from where that one ends, right here, that's where I'm going to start my blue one that goes straight up. Now I can find the result. The resulting force would go from the very beginning to the very end. Put an R on it for result. And it sort of makes sense that that's the result. If you're being pushed west and north, it makes sense that your result would be northwest. In this picture, neither of, if I put this in, that's not the result. The result isn't going to go northeast. It's also not going to go that way, southwest. Neither of those make sense. The only way that makes sense is if you look at the picture redrawn tip to tail. So let's see, we need to figure out what's the magnitude of that force. The magnitude is like the length of it. This one they made easy for us. They made it go exactly perfectly west and perfectly north, so we have a right triangle. The magnitude is going to be the length of that black side, the length of the resultant, so we can do the Pythagorean theorem. I'll put an M for magnitude. And if we solve that, they want us to round to the nearest 10 pounds. We can find the magnitude of that vector. The next part is to find the direction, and the direction we said was always in standard position. So if I'm looking for the direction of that black vector, the result, I'm going to imagine an x and a y axis that starts right where that vector starts. And in standard position, I'd always start from the positive x-axis and rotate around counterclockwise. This angle is the direction. To find it, I'm going to find this one first using right triangle trig, and then I'll subtract from 180 to actually get the answer that I want. So to get this one, I have opposite and adjacent, so I'll use tangent. I can type that into my calculator. Make sure you're in degree mode. And get an approximate. I think there's a typo here. It says, what's the direction to the nearest 10 pounds? Directions are in degrees. So let's say, what's the direction to the nearest degree? So we'll round this number off to the nearest whole number. And then to actually answer the question, what is the direction, we're going to do 180 minus that number, and that'll be our final answer. So let's compare and see how we did. Here's part A. There we go. So part A, where we were finding the direction, they have a picture that looks almost exactly like ours. They did the Pythagorean theorem just like we did. And when they rounded it off, or they first got the 3,421, they said they wanted it to the nearest 10 pounds. So it should have been about 3,420 pounds. For part B, they did the tangent and they got this direction, which we called theta, they're calling A, and they rounded it off to about 63 degrees. Then they did a couple different things. What they're saying is the direction with the resultant force upon the piling is 27 degrees west of north. Now that's correct. It's not how I would say the answer. What they're saying is here's due north. This is going 27 degrees west of north. That's true. I would like you to always put your answers in standard position. And in standard position, we always start from the positive x-axis. So starting from this positive x-axis, if that's 63, that means the standard position answer for this angle would be 117 degrees. If you prefer answers like this, you're going to need to have a descriptor with it, like west of north. If you put your answer in standard position, then you don't need a description with it. If I see just an angle like 117 degrees, I'm going to assume that it's in standard position unless you tell me different, unless you tell me, no, I mean it's that many degrees west of north. The homework in this section is just a few problems out of the book, but also the worksheet that you got. It was stapled to the vocab worksheet that you did last night. I want to go through and do a couple examples from that worksheet, and for it you're going to need a protractor and a ruler. Because we're actually going to measure some vectors and see what's going on and draw the resultant and label it. So let's first give these each a name. This one is vector A, this one's vector B, and this one is vector C. And I want to get you started on number 1. For number 1, you're doing vector A plus vector B. So what you're going to do is you're going to make an exact copy of vector A and put it down below number 1. To make an exact copy, that means you need to use your ruler and actually measure out exactly how long this is and do your best to make it go in that exact direction. I'm going to use Smartboard to help me out. For you, you're going to have to measure it, figure out how many centimeters long that vector is, make it go in the same direction, and draw a vector A. Then you're going to do the same thing. We want to do A plus B. So then you're going to measure out vector B, exactly how long it is. And you're going to want it to go in that exact direction. So you're going to measure the angle in standard position and see how many degrees it is. And you're going to make an exact copy of vector B and make it tip to tail. So put it right at the end of where vector A was. The result goes from the very beginning to the very end. So there's a sketch, it's black in my picture, of the result for A plus B. Now for up here, that's all you have to do. At the bottom of the page, it asks you to use right triangle trig and go back and find the magnitude and direction of each result. Instead of using right triangle trig, I just want you to measure. Use your ruler and measure how long is the result. And you'll write the magnitude of the result equals, and tell me how many centimeters it is. And then we also want the direction of the result, so you're going to measure the angle that it makes and write a number down for that. You're going to do that for all 6 vectors here on the front, sketch a picture of it. Once you have the result drawn in, do the magnitude and the direction. On the back, I'd like you to skip 7, 8, and 9. And 10 was the example with the 2 bulldozers that we just did. So you can copy that over from your notes. So the homework again in 8.1 is the worksheet and a few problems from the textbook. We're also going to do section 8.2 and 8.3 today.